Active molecular membrane transport, a presentation by Josipa and Anna. The first type of active molecular membrane transport is primary active. We will be using the example of the sodium-potassium pump.
Potassium pump is embedded in the heads and tails of the phospholipid bilayer. It has 3 round spots for red sodium and 2 green triangular ones for potassium. Both will be moving against their concentration gradient because ATP is used in primary active transport and provides the fuel for this. First, the sodium-potassium pump is open to the inside of the cell and has a high affinity for sodium ions, so it binds 3 of them. This triggers the pump to break down the ATP, so one phosphate group is attached to the pump and ADP is released as a byproduct. This phosphate group makes the pump change shape, opening to the outside of the cell, and now the pump has low affinity for sodium ions, so it releases them to the cell's exterior. However, now the pump has high affinity for potassium ions, and it will bind 2 of them. When they bind, they trigger the pump to release the phosphate group that was attached to the pump. When the phosphate group is gone, the pump will change back and open towards the inside of the cell. Now it has low affinity for potassium ions, so they will be released to the interior of the cell, and the cycle can begin again. The next type of active molecular transport is secondary active. An electrochemical gradient is used as an energy source to move molecules against their gradient and thus does not directly require a chemical source of energy, such as ATP. One type of secondary active transport is a symporter. The protein carrier is still embedded in the phospholipid bilayer, but has a smooth interior and not specific spots for molecules. In this example, glucose is represented by yellow circles, highly concentrated on the inside of the cell, and sodium by black triangles, highly concentrated outside the cell. The protein carrier lets the sodium ion move down its concentration gradient, and this causes the carrier to simultaneously bring the glucose molecule against its concentration gradient. This happens by using the sodium gradient's energy to transport the glucose molecule against its own.
Another type of secondary active transport is an antiporter, which is also a smooth interiored protein carrier within the phospholipid bilayer. Calcium is represented by yellow circles highly concentrated outside the cell, and sodium is represented by black triangles also highly concentrated outside. The protein carrier lets the sodium ion move down its concentration gradient to the inside of the cell, and the carrier simultaneously brings glucose against the concentration gradient to the outside. The protein carrier uses the energy of the sodium gradient to transport the calcium molecule against its own. Thanks for watching. This has been primary and secondary active typical molecular membrane transport.